Okay, now we'll go study about each amplifier in depth. The first voltage series amplifier we'll take. The voltage series, as the name indicates, input side is series. Input side I'm going to use series mixing, right? The input side I'm going to use series mixing. So you will be adding the feedback voltage at the input side. Series mixing. Output side, it is voltage sampling. So you will have this output voltage, you will be finding it across RL. And since you have the input side is series and output side is going to be input side, I'm going to have series mixing. So input side you will have Thevenin's theorem. Series nale, whenever you have a word series, you will have Thevenin's theorem, because in Thevenin's theorem you know it is voltage source in series with a resistor. And whenever you have the term shunt, you will go for Norton's theorem. The voltage series feedback is also called as series voltage series feedback. We have seen the name, right? Voltage series feedback is called as series shunt feedback. So, but since you have voltage in the output side also, you have the term voltage. We'll be using voltage source at the output. So remember, the diagram also comes from the name. So drawing the diagram, you should do it from the name. For input side, see the second term, series. Series means Thevenin's theorem. Output side, I have voltage, so I should have voltage source. The input side also I have voltage source. Output side also I have voltage source. So in voltage series feedback amplifier, both the input and output side is replaced by Thevenin's model. And since it is series mixing, voltage will get added in the series side at the input side. You know, in series mixing, voltage is additive, current is same. So I am mixing the feedback voltage along with the input signal. Okay, so the input resistance Vs Ri. See, this dotted line is your amplifier. All the other thing outside this dotted line are connected by U. So an amplifier will have an input resistance and you will have this voltage source output resistance. This is a simplified model of your amplifier, and other than this dotted line connecting the external source, connecting the load, everything is going to be what we are going to do. So now we are going to find the input and output resistance for this amplifier. And effectively what is going into your amplifier is Vi, and what you measure across RL is going to be V0. That notations are simple, and the current entering the amplifier is II, and the current leaving the amplifier is I0. And always when you are measuring output resistance, it is excluding your load. That's why you see before the load they have given R0F. After load, whatever you measure, it is going to be R0F dash. It is considering your load. Generally, when you measure output resistance without load, that is called as R0F, output resistance with feedback. So whenever you consider the load, it is called as R0F dash. So this voltage series amplifier, you know, we have it is going to have an voltage